All right, so let's look at this question here. Okay, let's look at this question here. So this question is on binary operations. Okay, it's on binary operations, and it is a very interesting question. Okay, it's a very, very interesting question, and we're going to tackle it today. Okay, we're going to tackle it today. So let's read the question. Okay, so the question they're saying, define a set, okay, G with plus 7, okay, and then the set G contains 0, 1, 2, 3, 4, 5, 6. All right, so this plus 7 here simply means modulo 7. Okay, it means modulo 7. Okay, so modulo simply means you're dealing with remainders. Okay, so the first question here, they're saying construct a table for G. Okay, construct a table for G. So how are we going to construct that table? Okay, so I'm just going to construct a table like this. Okay, so here, okay, I'm going to put uh, plus and then 7. Okay, so simply meaning modulo 7. Okay, going to put plus and then 7. Simply means modulo 7. Okay, and then here I'm going to put the elements that I can see in set G there. And then even here, I'm going to put the same elements. So in set G, I can see 0, I can see 1, I can see 2, I can see 3, I can see 4, I can see 5, I can see 6. We're going to extend the table. And then here 0, 1, 2, 3, 4, 5, 6. Okay, so let's draw a proper table here. So I'm going to make columns and rows here. Okay, so let's make a proper table. Okay, so can move that guy. Okay, and then we make the columns now because those were the rows. Make the columns. Okay, so this is the table that we come up with. Okay, so that is a proper table now. So in this table, okay, this table here is called a Cayley table. Okay, so Cayley table. Okay, so this is the Cayley table here. So this modulo 7 here, okay, it's an operation. Okay, it's an operation and it's also a binary operation. So this simply means here I'll be adding 0, okay, plus modulo 7, 0. What am I going to get? Okay, so modulo simply means whatever you're going to get here, okay, are just going to be remainders on applying this operation here. And since this is modulo 7, it means all the numbers that I'm going to write here, okay, they should be less than 7. Okay, so they should be from 0 to 6. That's what it means. So 0 plus 0, I get 0. Okay, and then 0 divided by 7, because I'm using modulo 7, it's going to give me what? 0. Remainder what? 0. So the remainder is the thing that you're going to be putting in this table. Okay, so I'll put the remainder 0 there. 0 plus 1, it's 1. Divided by 7, that will give me what? 0. Remainder what? 1. Okay. 1 divided by 7, it's 0. Remainder 1. So the 1 is the remainder that you put there. Okay. And then you do the same for the 2, for the 3, for the 4, for the 5. So as long as the number is less than 7, okay, then we can just get it as the usual addition. So you can see 0 plus 0, 0, 0 plus 1, 1, 0 plus 2, 2, 0 plus 3, 3, 0 plus 4, 4, 0 plus 5, 5, 0 plus 6, 6. Okay, but remember that this is modulo 7. So this one here works by just using the usual addition there because all the numbers that I'm going to be getting are less than what? 7. Okay, but you can see that all these here are gotten by using modulo 7. For example, 0 plus 5, that will just be 5. And then I divide this 5 by 7. I'm going to get what? 0. And then remainder what? 5. Okay, no wonder I put 5 there. So now let's see what is going to happen in the second row there. So 1 plus 0 is going to give me what? 1. 1 is less than 7, so we can just write it as 1. Or if you want, you can say 1 plus 0, that is 1, divided by 7, it will be 0, remainder 1. So the remainder is the one that we put there. Okay, 1 plus 1, that will be 2, 1 plus 2, 3, 1 plus 3, that will be 4, 1 plus 4, that will be 5, 1 plus 5, that will be 6, and then 1 plus 6, that will be 7. So now that's where it's hot. So I can't write 7 here, okay? Instead, what I'm going to do is that I'm going to say this 1 plus 6 is 7, right? So since we're doing modulo 7, it will be 7 divided by 7. This will be 1. And then what is the remainder? Okay, the remainder is 0. So here I'll put 0. Okay, so whatever we're going to be putting here, these are just remainders. Okay, we go to the next one. 2 plus 0, that will be 2. 2 plus 1, that will be 3. 2 plus 2, 4. 2 plus 3 there, that will be 5. And then 2 plus 4, that will be 6. 2 plus 5, that will be 7. But I can't write the 7 there. Okay, so I use the definition of a modulo. It will be 7 divided by 7, that will be 1. Remainder what? 0. 2 plus 6, that will be 8. 8 divided by 7, that will be what? 1. Remainder 1. So I put 1 there. Okay, so 3 plus 0, that will be what? 3. 3 plus 1, 4. 3 plus 2, 5. 3 plus 6, 6. 3 plus 4, that is 7. But I can't write 7 here. So I do 7 divided by 7, that will be 1, remainder 0. Okay, 3 plus 5, 8. 8 divided by 7, 1, remainder 1. Okay, and then 3 plus 6, that would be 9. 9 divided by 7, it will be 1, remainder 2. Okay, all right, the 4, we do the same. 4 plus 0, that will just be 4 plus 0, that will be 4, plus 1, that will be 5, plus 2, that will be 6, 4 plus 3, 7. I can't write 7 here. I'll say 7 divided by 7 is 1, remainder 0. So I put 0 there. 4 plus 4, 8. 8 divided by 7, 1, remainder 1. Okay. 4 plus 5. Okay, 4 plus 5 gives me 9. Okay. 9 divided by 7, 1, remainder 2. And this one here would be 4 plus 6, that would be 10. 7 into 7 into 7 into 10, it is 1, remainder 3. Okay, so you always put the remainders here if you are dealing with modulo 7 there, or any modulo 5, or any modulo. Okay, the next one is 5 plus 0, that will be 5. 5 plus 1, that will be 6. 5 plus 2, that will be 7. Can't write 7 here. Okay, I write its remainder. So it will be 7 divided by 7, 1, remainder 0. So this will be 0. 5 plus this, 8, remainder 1. 5 plus, it will be 9, remainder 2. 5 plus that, 10. It will be remainder 3. 5 plus 6, 11. 11 divided by 7, that will be 1. Remainder what? 4. Okay, we go to the last one. So this will be 6 plus 0, that will be 6. 6 plus 1, that will be what? 7. I can't write 7, so I divide it by 7, then the remainder is 0. Okay, and then 6 plus 2, that will be 8, the remainder will be 2, plus 3, the remainder will be 3, plus 4, the remainder will be what? Okay, because that will be 6 plus 4, the remainder is okay, so okay, so here the remainder should have been 2, right? So yeah, so because this is 2 plus 8, 2 plus 2, that is 8. 8 divided by 7, that is 1, remainder 1. Okay, and then 6 plus this is the one that gives me remainder 2. Plus 4 gives me remainder 3. Plus 5, it gives me remainder 4. And then 6 plus 6, that is 12. 7 divided into 12, it's 1, remainder what? 5. Okay, so this is our Cayley table here. We have constructed a table for what? For G. Okay, constructed a table for G. Okay, and then we can now go on and find or answer the other questions there. So the other questions now will all be based on this table here. No wonder we were what? Drawing the table in the first place. Okay, so everything else that we are going to do is just going to be based on this table. So let's get this table here and clean it up. Okay, so that is our table there. So we just made it smaller so that we have enough space to solve the other questions. Okay, so this is my table there. There's still remaining some things here. Okay, so this is our table here. So let's put it here. Okay, this is our table there. All right, so now we'll be answering all the other questions based on this table. Okay, all right, so the first one they're saying, is the operation closed? Okay, so is the operation modulo 7 closed on this table here? So closed, okay, simply means the closure property. So what is the closure property? It simply says that, okay, if I get two elements from a certain set and then I apply a certain operation, the answer that I should get should always be from that set. So the set here was this set G. Okay, this was the set G here. So if they ask you, is the operation closed? You're going to look at all the answers that you got here. Okay, are all these answers, okay, within this set? Okay, the answer is yes, because I can only see 0, 1, 2, 3, 4, 5, 6 in all of the answers that were found there. Okay, there's no number that is less than 0 or any number that is greater than 6. So because that property, I can see it, okay, I can see that all these answers here are part of this set here. Okay, so we're going to say yes, the operation is what? Is closed. Okay, so I'm going to say yes to I. So the operation is closed. We say yes there. Okay, number 2, is the operation commutative? Okay, is the operation commutative? So there, I'm going to show you two methods. Okay, one is just by looking at the table. The other one is by doing some sort of math. Okay, so let's start with the one that you are familiar with. So if an operation is commutative, okay, then adding or relating two elements with that operation in any order is going to give you the same answer, right? Okay, so you're going to pick any two numbers here. So let's say I pick 1 modulo 7. Okay, so I pick 1 modulo 7 and then I pick 2. Okay, so the operation is this modulo 7 here. So is this here equal to 2, okay, modulo 7, 1? If these two are equal, then we're going to say this operation modulo 7 is actually what? Commutative. So let's try. So 1 modulo 7, 2. So that would be 1 here. This is the 1. Modulo 7, 2. What do I get? So 1 is there, 2 is there. So I come down, I go to the right. I found 3. So the answer there is 3 is equals to. Is it equal to the same as if I do 2 modulo 1? So 2 modulo 1, I am here. Okay, and then the 1 is there. So always the number that you are starting with should be in this first column here. And then the other number there should be in the first row. So this is 2 modulo 7, 1. So 2 modulo 7, 1, it also gives me 3. So this is 3. Okay, so you can check with any two elements of your choice. So because this is true, we're going to say yes, it's what? Commutative. Okay, but if you don't want to use this, you can use another method, okay, just from the table. So from this table, I'm going to draw a straight line, okay, in the main diagonal. So the main diagonal starts at this point here, and then it goes all the way to that point there. So you've seen the line that I've drawn there. Okay, so now you start checking what is on either side of this line. So I can see 1, 1, okay, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5, okay, 6, 6, 6, 6, 6, 6. Okay, I go to 0, 0, Where's the 0 now? So this is 0, 0, 0, 0, 0, 0. So you see that it's like this line is a reflection of whatever is below it. Okay. So if I go here, it will be 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 4, 4. So you can see when I draw the line there, okay, I have like a mirror line. So everything that is below the line, it's the same thing that is above the what? The line. So if that property, if you notice that, then you're going to say it's what? Yes, it's what? Commutative. So I'm going to write here, number 2, yes, it's what? Commutative. Okay, but if they ask you to show your working, you can simply use that example that we did at the first. All right, and then what about associativity? Okay, so associativity, we're just going to pick any 3, okay, elements, and then apply the operation, which is modulo 7, and see if they are going to give us the same answer. So I'm going to say, let me say I pick, okay, let me say I pick, okay, let me first give the formula in general. So if I have A, uh, modulo 7, maybe B in brackets, then modulo 7C, this should be the same as A modulo 7B, okay, modulo 7C, and then this B and C are the ones that are in the brackets. So simply meaning that it doesn't matter which one is in the bracket. So here I'll pick 0 modulo 7, 1 in the brackets, then modulo 7 what? 2 is equals to on the other side, it will be 0 modulo 7, and then in the brackets, I have 1 modulo 7, 2. So are these two the same? So we start from here. So what is 0 modulo 7, 1? So 0 modulo 7, 1 is just 1. Okay, it's this one here. Because this is 0 modulo 7, 1. So it's 1. So I'll put 1 there. Modulo 7, 2 is equals to. Here, I have 0 modulo 7, and then I find whatever is in the bracket. So that is 1 modulo 7, 2. So 1 modulo 7, 2, I get 3. Okay, so I'm going to put 3 here. All right, and then now I do 1 modulo 2. So 1 modulo 2, I get what? 3. Okay, 1 modulo 7, 2, I get 3. So this would be 3 is equals to, what about 0 modulo 7, 3? So 0 modulo 7, 3, I get 3 as well. So that would be 3. So this property is satisfied. So we're going to say yes. So you can choose any 3 letters from, any 3 numbers from this table here. So I'm going to say yes. It's what? Associativity. Okay, it's associative, I mean. Okay, so the associativity property, we've shown it there. So next now we'll be looking at how to find the identity element. Okay, so here they're saying find the identity what? Element. Okay, find the identity element. Now, before we continue, okay, I'd like to show you guys something. Okay, so this question here came in your test 1. Okay, it was, where is it? So question 1, this was question 1. It was here. It was on part B2. Okay, question 3B2. This was the question here. So it came in your test 1. You've seen it, this one here, the one that we are solving. Okay, also this same question here, it's there in tutorial sheet what? 2. So this tutorial sheet has like 25 questions. So if you go to question 23, where's question 23? So you can see this question 23 here. Okay, that's the same question that came in your test. Okay, that's the same thing that we are solving there. Okay, that's the same thing that we are solving. So if you're struggling with math, okay, or physics, or chemistry, or biology, or any course that you are taking, okay, I would like to invite you guys to our platform, because on our platform, we have videos for all these questions that you can see here. Okay, we've solved all these questions and the videos are there well explained. You can learn at your own time, at your own pace, even in your blankets. Okay, so it doesn't matter where you are, the videos are available online. So you can actually access them from your phone or from your PC. Okay, so you can see all these questions on partial fractions as well as all these other questions on binary. You can see them here. all these questions that you can see here in this tutorial sheet, okay? We have solved them, explained them in details, okay, so that you can be able to understand how to go about them. Okay, so make sure you subscribe on our website, which is discretelearning.com, or you can search our app, which is Discrete Learning Institute on Play Store. And then the good thing about the app is that you'll be able to download the videos. Okay, you can download the videos and you can watch them offline. So you don't always have to have bundles to learn using our platform. So make sure you download the app. Just go to Play Store and search Discrete Learning Institute. We have videos to all these questions that you can see in this tutorial sheet here, as well as all videos. This was tutorial sheet 1. So all videos for this tutorial sheet 1 are available on our website, okay, on our mobile app. So you can easily find them there. Again, was test 1, okay, all the videos for test 1. Okay, this was what now? So question 1, you can see it there. We've solved already. The videos are there. Question 2, question 3, everything is there. You can access them at your own time, at your own pace, and learn. Okay. All right. So I thought I could invite you to our learning platform. Okay. So if you want to contact me, you can call or WhatsApp me on 0779 96 40 and then 10. So that is my number there. So you can call me or you can WhatsApp me. You're going to find me. That is what? Tutapo Solutions. Okay, so yes. So let's continue with our question now. So how do we find the identity element? Okay, how do we find the identity element? So we're going to define the identity element by the letter E. Okay, so we're going to say let E be the identity element. Okay, so the identity element, the way it works is that when you apply the operation, okay, on this identity element with any number, you're just going to get the same number. So for example, in general, if you do maybe 5 multiplied by 1, you're going to get 5. 5, let me say 10 multiplied by 1, you're going to get 10. So this guy here, the 1, is what we call as the multiplicative identity. Because when you multiply any number by 1, you're just going to get the same number. So this one here, when it comes to multiplication, it's the identity element. Okay? And then when it comes to addition, it is 0. So 5 plus 0, you're going to get 5. 10 plus 0, you're going to get 10. So any number that you add to 0, you're going to get the same number. So 0 is the additive, it's the identity element for addition. Okay, so now here we want to find the identity element for modulo 7. Okay, so we've said the first step is to say let E be the identity element. So the way the identity element works is that when you do any number from here, so let's say I'm representing that number by A. So if I do A modulo 7 with this identity element, the answer that I should get should be the same as the identity element modulo 7A, okay, and this should just give me the same number itself, which is A. Okay, so this is the rule that we have to follow here. So when I combine any element with the identity element, then I should get that same element. So we want to find that element here. Okay, so which element here is acting as the identity element? Meaning that when you combine with that element, okay, you're still getting the same value that you are getting. Okay, so here what you just have to look for is just 2 columns or 2 rows that have the same things. Okay, that have the same things that are following each other. Okay, so for example, you can see here there's 0, 1, 2, 3, 4, 5, 6. Even here 0, 1, 2, 3, 4, 5, 6. So these 2 rows here are following each other and they have the same things. Or you can look for columns. Okay, you can see 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So they have the same things here and they're following each other. So it means the guy at the corner there is our identity element. Okay, so you can try to use this formula with the identity element. So the identity element here is 0 because when I combine it with any other thing, I'm just getting the same other thing. So for example, if I do 0 modulo 7, 0, what do I get? I get 0. Okay, 0 modulo 7, 0, I get 0. What about if I do 1? Okay, if I do 1 modulo 7 with the 0, what do I get? So 1, okay, modulo 7, 0, I get 1. 2 modulo 7, 0, I get 2. Modulo 7, 0, I get 2. Okay. 3 modulo 7, 0, I get 3. You can check. 3 modulo 7, 0, I get 3. 4 modulo 7, 0, I get 4 as well. And 5 modulo 7, 0, I get 5. 6 modulo 7, 0, I get 6. So if I combine this 0, okay, with any element, I'm just getting the other same element. Okay, so the identity here is just going to be what? To be 0. Okay, so we're going to say the identity element there is 0. Okay, the identity element there is 0. All right, so we've done part 4, and let's look at part 5. Okay, so part 5, they're saying find the inverse of each element. Okay, find the inverse of each element. So the inverse of any element will be satisfying this property. Okay, so if my element is A, okay, and then I do modulo 7 with its inverse. So the inverse, we're just going to be saying the same thing, but raised to power -1. So if the inverse of A is A to the power -1, then the answer, once I do A modulo 7 with its inverse, should always be equal to the identity element. Okay, so that is the equation that we are going to be using in order to find the what? The inverses of each element. So now here we perfectly know the identity element because we are from finding it there. Okay, we know the identity element there. So the identity element is 0. So I'll go to this table here that I have. Okay, and then I'm going just to mark the position where I have 0 there. Okay, so those are the positions where I have 0. So it means I can now start finding, oh, this is 0 here. I forgot that one. I can now start finding the inverse of each element. So we start with the element of 0. Okay, we start with the inverse of 0. So 0 modulo 7, 0, it gives me 0. So 0 modulo 7, 0, it gives me 0. So simply meaning that the inverse, okay, of 0 is 0. So I'm going to write it somewhere here. So inverse of 0 is what? 0. Okay, because when I combine it with the modulo 7, I'm getting 0. Okay, or any other combination that you may have there. It won't be always modulo 7. It can be modulo 5. But as long as those two, they're giving you the identity element, okay, then we're going to say whatever is here is the inverse of whatever is there. Okay, so that's the inverse of 0. We go to the inverse of 1. So 1 modulo 7, okay, uh, which one gives me a 0 when I do 1 modulo 7 something? So 1 modulo 7, 6 is the one that is giving me a 0 there. You can see it, okay? So 1 modulo 7, 6 is the one that gives me 6. So simply meaning that the inverse of 1 is equals to what? To 6. Okay, let's find the inverse of 2. So inverse of 2, this one here, it will be 2 modulo 7. And then which number gives me a 0 when I combine it, the 2? So 2 modulo 7, 5. I get 0. So meaning 5 is the inverse of 2. So the inverse of 2 would just be what? 5. Okay, let's look at the inverse of 3 now. So 3 modulo 7, uh, if I do 3 modulo 7, 4, I get a 0 there. Okay, so that's the inverse. Okay, so modulo 7, 4, I get 0. So meaning that the inverse of 3 is equals to what? To 4. So now you get the idea of how we are finding these things, right? So let me just write the other ones. So meaning the inverse of 5, the inverse of 4 now is going to be equals to, okay? So which one gives me a 0 when I combine it with the 4? That's what we are looking for. So 4 modulo 7, 3. It gives me 0. So the inverse of 4 is 3. Okay. The inverse of 5. Okay. So 5 is here, modulo 7, 2. Okay. I get what? 0. So the inverse of 5 is 2. Okay. What is the inverse of 6? The inverse of 6 is, I have 6 here, modulo 7, 1. I get 0. So the inverse of 6 is 1. Okay. So we have found everything. So the inverse of 0, we said it was 0. The inverse of 1, we said it was 6. The inverse of 2, we said it was 5. All right, so found the inverse for each what element there. Okay, so simply meaning that this other question that was saying find the inverse of 1 and 4, we've already answered it. So the inverse of 1 is what? 6. And then the inverse of 4 is 3. All right, so that's how we can answer this question. I hope you've actually learned a lot. Okay, so uh, it won't come as the same exact modulo 7. Okay, they can put modulo 5, which means whatever numbers that should be present here should be less than what? 5. Or in other case, they won't even bring a modulo 1. They'll just bring a normal operation. Okay, they can say A star B is equals to maybe A multiplied by B. So it means here you'll be using this operation there. Okay, so I hope you've learned something here. Thank you so much. Okay, so now let's look at the next question here. So the next question, they're saying a binary operation star is defined by A star B is equals to the root of A squared minus 3B. Okay, so the question is find minus 5 star 3. So minus 5 star 3 is equals to the root of, okay, this minus 5 is acting as the A, and then the B is the 3. So this A squared will be minus 5 squared minus 3, and then the B is 3. So this will just be the root of 25 minus 9, which will just be the root of 16. So this will just be what? 4. Okay, to just be 4. And that is all. Okay, that is all. All right, so that's the answer there. All right, so now guys, if you're enjoying this video, you're learning from it, I would like to tell you that we have a premium platform where we can access all our videos and all our solutions to tutorial sheets, past papers, even topic lessons. Okay, so let me show you. So when you go to Google Chrome, either on your phone or your laptop, just type in discrete.learning.com. So discrete.learning.com. Okay, and then you go there. So this is the website that has been designed for you, so you can see from average to A plus. So as long as you use this website, I can guarantee you are going to pass. All right, so we have the 4 NS courses that you can see there. There's math, chemistry, physics, biology. So you can subscribe for any. Okay, so if you haven't yet enrolled, here it will be written not enrolled. Okay, but once you subscribe, you pay for the course that you want. Yeah, it's going to show enrolled there. Okay, so if you don't have an account, please just check the link in the description below here. There's a video that will help you create an account, and then you'll be able to log in and pay for the course that you want. Okay, so for example, if I open math, okay, there are 2 folders there. So you go in general mathematics if you're in first year. So you go general mathematics there. Okay, so you just wait for it to load. Okay, so once it loads, you can see the 4 folders. There are topic lessons there. So for any topic that you're going to learn in math, we have videos there clearly explaining all the concepts, and there are also some notes that you can write. Then in this folder, there are summarized notes. Okay, so very much summarized, direct to the point of exactly what you want to know. Okay, or what you need to know in order to pass any assessment. Here there are tutorial sheets and assignments. So all the tutorial sheets, we have full videos here. You can check them out once you subscribe. So you are going to check them out. And then here we have the past quiz, test, and final exam papers. So we have videos there, so you can check it out. Okay, you can go in that folder and then you check it out. So if, for example, you go to the tutorial sheets here, okay, so it will depend from the university where you are. So if, for example, you are from Apex, when you open this folder for tutorial sheets, you're only going to find the videos for Apex. Okay, if you're from Cavendish, you're only going to find videos for Cavendish. All right, so let's say, for example, you are from maybe Mukuba. So you open Mukuba. So once you open this folder, okay, you're seeing there are two intakes there. So there's the past intake, the 2022-2025, and then we have the 2025-2026, which is currently running right now. So if you go in this folder here, you're going to see that you're going to find tutorial sheet 1, tutorial sheet 2. So we have videos for all the questions in tutorial sheet 1 and tutorial sheet 2. And all the tutorials that are going to be coming, we're going to be solving them and uploading them here so that you can learn at your own time, at your own pace. Okay, even in your blankets, you'll be able to learn. So now, if you like to register, okay, you can just follow the link in the description below. It's going to tell you how you can register and make a payment. Okay, it's an automated system. Okay, so it does everything automatically. So even in the night, when you just wake up 02, when you hear kudo kuku, you just wake up, boom, you'll be able to what? To register. So my number is 0779 96 40 10. So if you're interested and you'd like to register so that you can improve your academic life, please hit me up on that number. You're going to find me. My name is Tutor Solutions. Okay, so even in the past papers, you'll find a similar arrangement. You're going to find the past papers there. Okay, so thank you so much for watching this video and for supporting Discrete Learning Institute. Continue learning fast and easily.